So, greetings, guys, and welcome back to the open world game tutorial series. I'm never gonna leave this series behind. So, today we're gonna continue where we left off. So, we had this looking around system for our character, which works pretty nicely, except that what I noticed when playtesting this is that when I bring the mouse down, the camera actually turns up, and when I bring the mouse up, the camera turns down. So it basically just inverted the top and bottom thing. So we have to change that. To fix that, just go to edit, project settings, and just full screen that and input, and then in the axis mappings in lookup, we're just gonna change the scale to -1 so that we can invert it. Now if we see, it works all fine. Yeah, so it works, yay. So now what we have to do is we actually have to try to move him, because he doesn't do anything at the moment. He's just in his basic T-pose. So what we're gonna do is we're gonna go to characters, rare and rare underscore BP, and then we're gonna add in here in basic inputs some of our movement inputs. So first let me just correct this to camera inputs, as mouse inputs isn't very a good name for this comment. So just now what we have to do is just go to edit, project settings, and we have to make a new input. So axis mapping, just add two more. So move forward and move right. There. Now we're gonna set two keys for all of these. So first will be W, second will be S. So just find your keyboard S, and we're gonna invert it again so he goes backwards, not forwards, with S. As you have seen in many games, while pressing S he goes backwards, and the same thing we're gonna do. So to move right we use D on our keyboard, and then A, so A for left, and then again we're gonna invert the A, so -1 there. Now if we go we don't need to save it because the project settings are saved automatically. When we go back here, then type in move forward. Here, there we go, we have our input axis, and then the same we can get move right too. Now to do anything with these, first we actually have to get our control rotation so that we can move forward or move right depending on which direction we're looking at. So we're just gonna get control rotation, and then we're gonna break this into its roll, pitch and yaw, and then after that we're only going to use the yaw to make a rotator, and then instead of connecting this to the X, we're gonna connect this to Z and just disconnect it. So break link to rotator, and then we need to connect it to the yaw, and then what we have to do after that is we need to get our forward vector and get our right vector there. So now using both of these, we're gonna add a movement input and then connect these executables, put the axis value into the scale value, and yeah, well, that's it. Now Control C, Control V, just copy paste it right over here, and just do the same thing for this also. In the world direction, just plug in the forward vector. Now why did we do all this? Well, we did all this so that first of all, we're figuring out the direction right here. In which direction do these movements depend on? So if like we are facing forward, we're gonna move forward by getting the forward vector, and if we are facing right or left, we're gonna get the right vector. And if we actually like are facing left, then this right vector will go into a minus value. So world direction, as you can see, it's plugged into that. So yeah, now we'll compile and save and try to play this. So once we are here, we can move around happily. Yay! So our job here is basically done. So to stay organized, we're gonna comment this movement inputs. It's gonna turn the bubble off because it doesn't look neat, and then just move it over here. Yeah, so now we have our movement input, so we can compile and save. And then now, but he's still standing in his T-pose. We need to get some animations for him. If you see, he'll walk around in his T-pose and he's not even breathing. He's just a lifeless character. We need to breathe life into him. So what we're gonna do, by default it will be set to animation blueprint. Okay, so just compile and save. And then now what we need to do is import some animations that are downloaded from Mixamo itself. So I have them on my desktop. Open world assets, and just go into here, animations, and you need to download these set of animations. So you need to download an idle animation, left sprint, left walk, right sprint, right walk, sprint, and walk. So we need to download all of these. We're just gonna create a new folder named not animations, animations there, and in this animation folder, we're just gonna select these all and drag and drop them into here. Now for the skeleton, we're gonna use the Dre skeleton, our character skeleton, so that we can like animate him, and leave all these settings to default and click import all. Now it's gonna import these animations, and then now just control save it. It didn't actually save, so control S. Okay, yeah. So now you can just test out these animations. Yeah, this one looks good. Looks good. Also, all of these animations need to be in place. Okay. So as you can see, if he's sprinting right in place. And in Mixamo, you can do that by just ticking the option. There's a check mark over there. So yeah, you can just check all of these, and for me they're working fine. So yeah, now to only just test this, we're just going to go to Dare BP, and then to our mesh, and then we're gonna use animation asset and idle. Now you see he's idle. So if we compile and save and go to the game, he's gonna be idle, but he's gonna be doing nothing except breathe. Yep, so this also looks weird. If we need to actually have him playing a set of animations, we need to use an animation blueprint. So just let's compile and save it and create a blueprint. So to create a blueprint, we first need a blend space. What is a blend space? Well, it automatically actually blends all of these animations and interpolates them for all speeds. So it is not practical to create an animation for each and every possible speed that the character can have. So the blend space basically interpolates them to do it for you. I'm just going to show you how it works. Just right click and go to animation and blend space. Now select the Dre skeleton, and let's see, Dre underscore BS means blend space. Control S, save it, then go ahead, and then now you have these two axes. on which basis you can just actually place these animations. So the vertical axis I'm gonna name speed forward, and then the horizontal axis I'm gonna name speed side. So this is the speed to the side and this is the speed forward, and in each of those I'm gonna have 12 divisions like so. And if you see this, we can now place animations. So first, in the middle, square in the middle, just place the idle animation there. Now also the speed side max can be 600, so not 6600, and here also 600. So now if we say place walk in like 300 and then sprint in 600, now you see what it does. So we are basically walking at 300 and we're sprinting at 600. So isn't that amazing? That's pretty cool, right? So now what you have to do is, we'll just basically plot all these animations wherever you want. So and then they will they'll I'll just left walk right over here, and then left sprint. I'm gonna do it right over here. I'm just gonna move this to the middle. Now if we just preview this, so yeah, looks great, right? If we see him from the perspective we're gonna be seeing him, yeah, so looks pretty cool. And then we're gonna do the same for the right thing, just right sprint. And we don't have any walk backwards animation yet, so we're just gonna leave it at that. Now if we save this, then go ahead, we can actually create now a blueprint which uses this blend space. I'll just create an animation blueprint, and then I'm gonna draw a skeleton and then click OK. And I'm just gonna say rare underscore ABP animation blueprint. Just Control S. And now what we have to do is basically just bring this blend space into here and just do that. Now what will happen is basically this will need a speed side and a speed forward. So we just compile this. This just randomly set something. So like if we change the speed forward to 600, compile, he will run straight. And if we set the this to like, well, let's set this to 0 first, and then we'll set this to 600. He'll just go into the left, as you can see. If we set this to 0, he'll go into the right. So yeah, that's okay. Actually though I'm just gonna go into this blend space and actually make this speed side minus 600. Or I'm just gonna make this 0. Actually I don't know what, minus 600 is fine. So now if we plug minus 600 into this, we'll go there. If we plug in plus 600 into this, we'll go there. So now we just want to change this value dynamically. So let's promote these two to variables. Speed side, promote to variable, speed forward, and then we're just going to like rearrange these. So there we go. Now if we compile, save it, there. So now we'll go to the event graph and basically we'll just determine like how much we want to keep this value. So first we'll get a reference to our character. How do we do that? Well, we just go to begin play, and then we cast to drar underscore bp. Objective, we want to get our character, player character. So get player character there, and we're just gonna promote this to a variable and call it char ref basically. So we have a character reference over here. So now what we can do with this character reference is that we can just bring it into here, and we want to set both both the speed side and speed forward. I'm just gonna hold alt and bring this in to set this and set this there. Now I'm just gonna collect the executables, and now we have the math part. So basically we need to get our velocity first for the speed, and then we're gonna get actor forward vector, and we need to get our right vector. So get actor the right vector. Now if we take out the dot product, I'll explain you all the math in the description. This can be figured out with basic trigonometry. So we just take out the dot product of this, then plug it into here. It is gonna return the value of the speed forward. Now if we just space this out a little, okay, and just can bring this closer, and then now if I take out the dot product of this and this and then plug it into there and then do some reordering, just reroute mode there, and then if I compile and save, I'll be ready to go. Also we need to use this animation blueprint first. So we'll just go to our drar character, and then in the viewport we're gonna use this animation blueprint, our drar animation blueprint. Compile and save, and so yay, it's working, right? Yeah, so now the final thing that we need to do, just ignore this warning, is that orient, it must be in here, in the spring arm of camera. It needs to be somewhere over there. So yeah, orient rotation to movement, you're just gonna select that, and then when we go to play there, now as you can see we have our running. So our character is now sprinting at a speed of 600. So in the next episode we're gonna teach him how to walk first, and then when we press shift we can run. So for now I guess this is a good place to end the video. So yeah guys, thanks for watching, and yeah, bye bye.